Welcome to NYNJPA Weather Educational Videos. Hello, today we're going to talk about soundings. We're going to cover the basics of soundings. We're not going to dive into all the nitty-gritty meteorological hardcore stuff yet. That'll come in future videos. But today I just want to go through the basics of what a sounding is. A sounding is basically a cross-section look at the atmosphere in a vertical component. Basically, what you want to see are what is the differences in temperatures from the surface to the upper levels. And by understanding what those differences are and what's happening in the atmosphere, you could tell what type of weather you're going to have. Now, at the left side here, this is the pressure. We start at the surface, or about 1,000 millibars, all the way up to the upper portions of the troposphere, which is 100 millibars. You also have the winds on the right hand side here. Okay, now the lines here, each full line equals 10 knots. A half a line is 5 knots. And then you see these triangles here, that's 50 knots. So for example, this right here would be 55 knots. This one right here would be 60 knots. Pretty easy to follow. This red line is your temperature. This green line is your dew point. And this blue line would be what the temperature would be if the red and blue line got together, basically condensed, or evaporation cooling, okay? So this would be what's called your wet bulb temperature right here. Now, another aspect is to follow this line right here. These are your temperatures. Now notice where they start. Let's say at 0. This is Celsius, by the way. Now notice it starts here, and then the line cuts back this way. This is how the temperature profile is aligned in our atmosphere. This is the dry adiabat and the wet adiabat. That's basically your rates of cooling in the atmosphere depending on a dry or moist environment. So here we are in this temperature profile, and this is what's called a severe thunderstorm profile. Why? Because temperatures at the surface are warmer than temperatures aloft at 850 millibars and even further up. So that means that the atmosphere, that a parcel like water vapor at the surface is able to rise to the upper levels. That's why you get these puffy cumulus clouds, because that's basically warm air rising. So in this environment, what you have is warm air rising, supporting the potential for thunderstorms to develop. You have a moisture saturated atmosphere at the mid levels. You have pretty high humidity also at the surface as well, but clearly there's more moisture at the mid levels. And then you have dry cold air at 500 to 700 millibars. So what that supports is a parcel like water vapor is able to rise from the surface rapidly up into the upper portions of the atmosphere. And think about a cloud right here, and basically that cloud growing higher and higher in the atmosphere as that piece of water vapor is able to rise further and further up into the troposphere, and that's what produces your thunderstorm. And that of course leads to circulations in the atmosphere and supporting severe thunderstorms that could produce very heavy rainfall, strong wind gusts, and hail. Now another interesting aspect here would be the winds. When you have strong winds like this in this type of sounding, this is what's called straight line wind. All the winds are coming in at the same direction. Let's say if these winds were coming from the southeast at the surface and from the northwest at the mid levels. That's called a cyclonic circulation, and that would be an indication for tornadoes. So this is a sounding that would suggest thunderstorms with the capability of strong straight line winds, winds coming from the same direction, coming down from the mid-levels down to the surface, with wind gusts anywhere from 50 to 60 knots, possibly higher in some occasions if the winds could tap into this type of jet streak up here. So again, this is a severe thunderstorm sounding. Now what about a snowstorm sounding? This is from the Plymouth State Weather Center. And what you want to look for in a snowfall sounding are two key factors. One, obviously a moisture saturated atmosphere. And two, temperatures below freezing right here. So if the temperatures throughout the entire sounding are below freezing, this line here, this is what's called a snow sounding. Also notice that temperatures at the surface are warmer than aloft. That means that this is supporting the potential for what's called convective snowfall. Now you know what that means. That could be thunder snow, snow banding, very heavy snowfall is likely with this type of sounding. And then you end up with a more stable environment at the mid-levels, which is normal for a snowfall event, and then unstable once again at the mid-levels. So you have rising air, stable air, rising air. Also notice winds here are from the northeast, and then they veer off towards the northwest, or should I say southwest. So this is a perfect example of a winter storm sounding that could produce very heavy snowfall. You got a moisture saturated atmosphere, you have temperatures at all levels of the atmosphere below freezing, and you have strong winds coming in off the Atlantic Ocean, because this is over in New York City, coming off the Atlantic Ocean at the lower levels of the atmosphere, and also coming from the Gulf of Mexico in the southeast at the mid and upper levels. So this is a perfect sounding for what you would want for a winter storm. But what about an ice storm? That's where it gets more complicated. Again, this map is from the Plymouth State Weather Center. And in that situation, your surface you want below freezing. Here's your 0 degrees Celsius line. Okay, so at the surface you're below freezing, but at the mid-levels you're above freezing. So what you have here is snow developing at the mid-levels, right here around 500 to 600 millibars. Okay, basically between, should I say, 600 and 700 millibars, because you have very dry air between 500 and 600 millibars. So you have snow developing here. That snow falls through a warm layer between, let's say, about 700 and 850 millibars, and then it refreezes below 850 millibars. This is a sounding for sleet, because the snowflake that melted is able to refreeze for a longer period of time before hitting the surface. Now, if this warm layer was down to, let's say, 900 millibars or 950 millibars, that means that the layer of cold air at the surface is very shallow, and that is a sounding for, you guessed it, freezing rain. So this tells us quite a bit about the nature of the precipitation involved here in a storm. If you have temperatures below freezing at the surface and immediately slightly above freezing, let's say at 950 millibars, that is a freezing rain sounding. When you have temperatures above freezing at about 850 millibars, it's typically a sleet sounding. Now, there is a reason why New York City and the New Jersey coast typically do not see these types of freezing rain storms. And it's because the influence from the Atlantic typically keeps the temperatures slightly above freezing. If they're above freezing at 950 millibars, there really isn't much to keep that cold air in place at the coast. But as you move further into the interior, into your valleys like in northwest New Jersey, in northeastern Pennsylvania, this sounding could be a disaster for those locations, because that cold air is able to get trapped at the mid-levels of the atmosphere, and that warm air is moving right over that cold air, and that creates what's called lifting, and it causes isotropic lifting that produces periods of freezing rain and sleet. So this is a perfect example of an ice sounding. Each one of these soundings, as you go back and take a look at them, are unique. So you can't really go, if it doesn't look exactly like this sounding, then there's no severe weather. But there are basic rules here. When you see air rising aloft like this, that's a severe thunderstorm sounding. When you see air rising aloft here, and you have all below freezing, that is a snow sounding. Each one will look different, slightly different, a few little unique features to it, but you get the idea here. And then, of course, again, you have a sounding where air is rising initially, and then it's falling under this warm layer. It's called a non-rising layer. You can't really call it stable completely. That, again, is an indication of precipitation developing. And in the winter, when you have this warm layer trying to invade over a cold layer, that is a perfect signal for the potential for sustained, moderate to possibly heavy precipitation over your location. Well, that is a brief discussion on soundings for today. I hope you enjoyed it. Again, NYNJPA Weather will be issuing these weekly education videos every week for the foreseeable future. I hope you enjoy it. Of course, I'm your meteorologist, Stephen DiMartino. Have a wonderful day. Stay safe out there.